5-6, adding expressions number 3. Add 1/3 n plus 2/3 and negative 1/6 n plus 1/6 m. So this and means plus. So they have this part and they want you to add it to this part. And because we're adding everything, we can just look for like terms. So I can see starting over here that I have an n, and over here I have an n. So I want to combine my n's. So first of all, I'm just going to write them. 1/3 n plus, this is a negative 6n. So I've gotten that one down and that one down. And now I have a constant because it does not have a variable behind it. And I have a term with a variable, but I don't have any other terms with m's. So I'm just going to, oops, that one needed an n. I'm just going to bring that one down because there's nothing to combine it with. And my 2/3. There's nothing to combine my 2/3 with. So it looks like the only thing I have that I can combine are these n's. But notice that one of them has a denominator of a 3 and one has a denominator of a 6. So I need to find a common denominator. So 1/3 and 1/6. I want to look at my largest denominator and ask myself, is the other denominator a factor of this number, or can it be divided into that number evenly? If the answer is yes, then this is my common denominator. So I'm going to set these each equal to 6 as a denominator. And then I would multiply by 1 here, so I'm going to multiply by 1 there. 1/6 equals 1/6, that makes sense. And then 2 or 3 times what gives me 6? Well, that would be 2. So if I multiply the bottom by 2, I multiply the top by 2, and that's going to give me 2. When I'm adding fractions, I bring down my common denominator, and I can see that I have 3/6. So 1/3 is equal to 2/6. This, however, is a negative 1/6. So I need to come back and think about this. 2 plus a negative 1 is not 3. Positive 2 plus a negative 1 is, this is a 0 pair, is positive 1. So this answer down here is positive 1 because this actually was a negative 1/6. So my answer is 1/6 n. So here's my n and my 1/6. So 1/6 n, I've taken care of this part. Now these cannot combine, so we're just going to add them, and this is my answer. 1/6 n plus 1/6 m plus 2/3. Down here, find the sum. Oh yay, I'm dealing with decimals. When I'm dealing with decimals and I'm combining like terms, I just have to make sure that I'm lining up my decimals when I put them in a column and add them. So first I'm going to change all of these subtractions to additions and change the following term to its opposite. So I can see in this first one I have a t, And it looks like there's another t down here. So I'm going to group my t's together. And that's a positive 4 1/10 t. So I'm going to put those together. This is using the associative property, remember, when I associate or I group things with each other. And I've taken care of my t's, so I like to put a little check mark there so that I know I don't have to look at those next time I go to something else. So I have a negative 4s, and I have a negative 0 3/10 s. I'll make sure that looks like an S and not a 5. I'll make my 3 a little larger. So I've taken care of my S's. So now all I have are my constants, and I have 4 5/10, and I have a negative 7 1/10. So here are my constants. Here are my S's, and here are my T's. Do I have to have these parentheses to solve the problem? No. Why do I put them in then? It helps me realize that these things are the same, these things are the same, and these are the same. So that when I'm looking at what do I need to do with all of this stuff down here, it helps me organize my brain. So I have negative 3 5/10 t plus 4 1/10 t. So what I'm going to do, if you remember the algorithm, when you are adding positives and negatives, you forget about the signs and you look at the absolute value of each of those, 4 1/10 and 3 5/10. You take the smaller absolute value from the larger absolute value. You actually subtract, and then you take the sign that originally was with the larger absolute value. And the larger absolute value is this number. It is a positive. If this one would have been larger, then the sign on the original number was negative. But today, when we subtract 3 5/10 from 4 1/10, our answer is going to be positive. I'm just putting that down there to remind myself. So over here, 4 1/10 minus 3 5/10. I'm going to have to regroup. It's going to make that 11. You can see my decimal point's going to come down. And I'm going to have 0 6/10. Now I have to put that t there. So I have a positive 0 6/10 t. So I've taken care of this part. Now I'm going to bring down my plus sign, and these are s's. So I'm going to put my s there so I don't forget that. And I'm adding again. And I'm adding the same sign. Oops, my addition sign just ran into my negative. I'm adding a negative and a negative, so my answer is going to be negative. So 4 plus 3/10 is simply 4 3/10. And then last, I have a positive 4 5/10 plus a negative 7 1/10. So again, I'm going to ignore the signs and I'm going to subtract the smaller absolute value from the larger absolute value, which is what we get when we ignore the sign. I have to line up my decimal points. This is my larger absolute value. It has a negative with it. So when I get done subtracting, my answer is going to be negative. So I'm going to do that subtraction right up here. and I get 2 6/10. It's a little blurry. So this is going to be a negative 2 6/10. So this is my answer. 6/10 t plus negative 4 3/10 s plus negative 2 6/10. Number 8. So notice they have 2a plus 8 in parentheses plus 4a plus 5 in parentheses. So in this second step, what we're doing is we're grouping all of our a's together. So here's an a, and over here is an a, which leaves me then just with the constants to group together. And then I'm going to pull these together. 2 plus 4 is 6a, and they already did the math for me on the constants. Number 9. I'm going to do the same thing here. I'm going to group my x's in these boxes, and I'm going to group my constants over here. I'm going to call this plus a negative 7. Okay, 2/7 x I'm going to put in this box, and 1/7 x I'm going to put in this box. And over here I have my negative 7, and I'm going to be adding a positive 8. So this is going to be x, so all I do is add my coefficients. 2/7 and 1/7 is 3/7. They already put the x there for me. Plus a 7 plus 8, because they're unlike terms. I have a positive and a negative. I'm going to ignore the negative sign for right now. I'm going to subtract 7 from 8. That's going to give me 1. And then I'm going to look back, and I see that my larger absolute value has a positive with it originally. So this is going to be positive. Number 10, find the sum. So again, first thing, I'm going to go through and change these subtraction to addition. Now I'm going to group all my like terms. I'm going to start just over here on the left. 8b, do I have any other b's? I do not. It's all by itself. Now I'm going to bring the 7 down. I just like to do things in order from left to right. There's a 7 plus a negative 4 plus an 8. Now those are all the same, so I'm going to put parentheses around them. Those are all the constants. So I've got those done. But I can see that I haven't dealt with the 6x. So I'm going to bring 6x down. And does it have anything to go with it? Nope. Plus 5c. Okay, none of my terms with variables had anything to go with them. So all I have to do is combine like terms right here. 7 plus 8 is 15. So I know that these two together are 15, and I'm going to add a negative 4 to that. So 15 plus negative 4. When I'm adding unlike signs, I'm going to ignore that sign. I'm going to subtract the smaller one from the larger one, and I'm going to get 11. And when I look back at my original problem, the number that had the larger absolute value, which was 15, is positive. So this is positive. And now all I have to do is bring down my other terms that could not be combined with anything. This is my answer. Number 11, combine like terms. That means the same as find the sum. When you combine, you put things together. When you add, you put things together. When you add, it's called the sum. So we're going to change this subtraction sign. And that's the only subtraction sign. So again, I'm just going to start on the left-hand side. Negative 3y. Do I have any other y's? Yes, I do. Plus 7y. Plus, what do I have? Negative 5. Plus 6. And then I have a 5m and a 9m. And I'm going to put parentheses around those things that are similar. These are y's, these are m's, these are constants. So again, I'm going to have a y down here. So I'm just going to look at my coefficients, and I'm going to be subtracting 3 from 7, and that's going to give me 4. And because the absolute value of the larger number originally was positive, this is a positive. Plus negative 5 and 6 is 1. And over here I have 14m. Number 12. Felipe is going to plant B sunflower seeds. So just say some number. Some number of sunflower seeds in one garden. And 5B plus 10 sunflower seeds in another. How many seeds is Felipe going to plant all together? All together means we're going to be combining things. We're going to add things. So here's his sunflower seed packet. I'm just going to draw a little picture. Here's one garden, and here's another garden. So he's going to plant B sunflower seeds in this garden. That's the first garden. And he's going to plant this many sunflower seeds in the other garden. How many seeds is he going to plant all together? Well, that just means we're going to add these two. And instead of writing them different directions, we're going to write them in the same directions. So we're going to take B plus 5B plus 10. And because this lesson is all about adding expressions, let's go ahead and simplify this and combine the like terms. I have 1B right here, and I have 5 B's there, so that's 6B plus 10. And that's seeds. It's a word problem. I should have a label. I don't know what B is. Make sure your B's look like B's and not like 6's. Last one, number 13. An art class is making a mural for the school that has a triangle drawn in the middle. The length of the bottom of the triangle is X. Another side is 1 more than 3 times the length of the bottom of the triangle. The last side is 2 more than the bottom of the triangle. Write and simplify an expression for the perimeter of the triangle. Well, I'm going to draw a picture of the triangle. And you can draw any old triangle you want. It's just a representation of what the problem is saying. So the first thing is the length of the bottom of the triangle is X. So there we go. This length from here to here, they're calling X. You might want to call it 20, just to give yourself some reference. And we can say it's inches. Then it says, another side is 1 more than, there are those words, 1 more than 3 times the length of the bottom of the triangle. So if we think about what the length of the bottom of the triangle is, over here we said it was going to be 20. So that would mean we would have to take 3 times the length of the bottom of the triangle, 3 times 20, and add 1 to it. But they're not calling it 20, they're calling it x. So this side is not 3 times 20 plus 1. This side is 3 times x plus 1. That's what this says. Another side is 1 more than 3 times the length of the bottom of the triangle. So now we come to the last part. The last side is 2 more than the bottom of the triangle. Well, we know the bottom of the triangle is x, and this is just 2 more than x. And when we see more than, we know that that number is going to go after whatever they tell us next. So the bottom of the triangle is x, and it's going to be 2 more than that. So now that we have our drawing, and if you wanted to put the arrows like I did before, you can. Write and simplify an expression for the perimeter. Perimeter is equal to side plus side plus side, because this particular shape only has 3 sides. So I'm going to take my x plus my 3x plus 1 plus my x plus 2. I'm going to combine all of my x's, which means I have 3, 4, 5 x's, and my constants, I have a 1 and a 2, so that is 3. So whatever units they are measuring this in, I would put that down, but they don't tell me, so I'm just going to call it units. And that is the end.